Hi, in this video we're going to be looking at sequences. Here we go. So here is quite a popular sequence. You probably recognise this one. It's going up by each term by adding on 4. We would call that the 4 times table. Now, to be honest, any sequence that goes up in 4s we call the 4 times table. Now, rather than write the word 4 times table out, we're going to write down 4n. That's a quick way of writing down the 4 times table. It just basically means that any number times by 4 will be in the 4 times table. And that would be the name of this sequence. That's the nth term for this sequence. Let's try another one. So this sequence, you probably noticed as well that this one is also going up in 4s. Okay, so any sequence that goes up in 4s really is a version of the 4 times table. I know this isn't the exact 4 times table, but I'm still going to write down that it's the 4 times table. Now the 4 times table usually starts off at 4. You've got 4, you've got 8, you've got 12, 16, 20 and so on. This sequence decided I'm not going to start at 4, I'm going to start at 5 and then jump 4 spaces and then jump 4 and continue doing that on and on. So what we're going to say is it's still a version of the 4 times table, however instead of starting at 4 it's decided to move 1 space in that direction to 5. So we would say it's the 4 times table moved over positive direction 1 number. And that is the nth term for this sequence. Let's try another one. So what's this one going up in? From 5 to 7 it's gone up by adding 2, adding 2, adding 2. Yeah, this is going up in 2s every single time. So I'm going to call it the 2 times table. Again, any number times by 2 is the 2 times table. Now the 2 times table should really start at 2, then 4, 6, 8, 10 and so on, jumping 2 numbers. This one has decided I'm not starting at 2, I'm going to jump 1, 2, 3 numbers and start here at 5 and then start my sequence off. So rather than start at number 2, it's jumped 3 spaces in the positive direction. Every number is jumped 3 spaces to the right. So we're going to say it's the 2 times table, because it's going up in 2s, but moved over in the positive direction 3 spaces. And that is the nth term for this sequence. What about this one then? So to get from 1 to 4, you've moved 3 spaces, 4 to 7, 3 spaces, 7 to 10. Yeah, this one's definitely definitely going up in 3s. So I'm going to call it the 3 times table. Now it's not the 3 times table, obviously, because the 3 times table should start at 3, 6, 9, 12, and so on and so on. Instead of starting at 3 though, it's decided to jump 1, 2 spaces backwards and say, right, I'm going to start my sequence here, and then jump 3, and then jump 3, and then jump 3. So how do we describe this? Well, it's still a version of the 3 times table, but instead of starting at 3 like a normal 3 times table, it's moved backwards 2 spaces. So that's how we would write down the nth term for this sequence. 3n take away 2. Right, here are some sequences for you to try. Pause the video here, have a go at them, and then I'll put the answers on the board in a second. Good luck. Okay, here come the answers. Give them a tick, give them a cross. Hopefully you've got them correct. Again, it's just a times table sequence, either moved forwards or backwards. That's all it is. Right, let's try some trickier ones. So, start at -2 on the number line, then go to -4, then to -6, then -8. I think that's going down in 2. Down in 2. Down in 2. Right, how do we describe that as a times table? I'm going to call that the -2 times table. Okay, so the -2 times table is -2, -4, -6, -8. So it's actually in the correct position as we start now. So that's -2, -4, -6, -8. It doesn't have to move sideways anywhere. So I'm going to call that the -2 times table. That is the nth term for this sequence. It was the -2 times table and it started at -2. What about this one then? So -1, then -3, then -5, then -7, -9. Again, it's going down in 2s. So again, I'm going to call this the minus 2 times table. The minus 2 times table. But in the previous one, the minus 2 times table should have started at minus 2. That's where it should start. But instead of starting there, it decided to start here. So it's actually moved one space to the right. Instead of starting at minus 2, it decided it wanted to start at minus 1. So I'm going to say it's the minus 2 times table still, but moved positive direction in the 1 space. And that is the nth term for this times table. A little bit trickier, but hopefully you've understood what I mean. Right, this one. So this one starts at minus 1 and then goes up to 5. I'm going to say we've added on 6 there. Let's check. Yep, add 6, check, add 6. I always check a couple of these just to make sure it's definitely going up in the same value every time. I'm going to call that the 6 times table. But it's not the 6 times table. Here's the 6 times table. 6, 12, 18, 24, and so on. Instead of starting at 6, like a normal 6 times table, it's moved backwards 1, 2, 3, 4, 5, 6, 7 spaces and decided to start here. So it moved 7 spaces in the negative direction. So what we're going to say is it is a version of the 6 times table, but moved backwards 7 spaces. And that is the nth term for this sequence. Right, this one. So starting at 3 and then going down to 1, that's moved backwards twice. From 1 to minus 1, that's also gone down in 2. Yep, going down in 2, going down in 2. So again, I'm going to call this the minus 2 times table. Now we've talked about this. The minus 2 times table should start at minus 2 and then go down 2 spaces, minus 4, down 2, and so on and so on. This one has decided rather than start at minus 2, it's going to jump 1, 2, 3, 4, 5 spaces and start at 3 instead. So instead of starting at minus 2, it jumped 5 spaces in the positive direction. So what we're going to say is it's still the minus 2 times table because it's going down in 2s, but it's moved 5 spaces in the positive direction. And there is the nth term for that sequence. Right, here's some for you to try. Some of them are going up, some of them are going down, so be very, very careful. Pause the video here, and I'll put the answers on the board in a second. Good luck. Okay, here come the answers. There we go. So hopefully you were okay with them. They are quite tricky, to be fair. They're also fairly rare, but we need to know how to do them if we see them. So in this part of the video, we're now going to use an nth term to generate some numbers in the sequence. We're going to find the first 5 terms in this sequence. This is the 5 times table, but we moved over 2 spaces. So what I'm going to do is find each of the first 5 terms in the 5 times table and then add 2 to each number. So what's the first number in the 5 times table? 5. Add 2 to it. 7. Second number in the 5 times table? 10. Add 2 to it. Third number in the 5 times table, 15, add 2 to it. The fourth number in the 5 times table, 20, add 2 to it. And the fifth number in the 5 times table is 25, add 2 to it, and we get 27. There is the first 5 numbers, or the first 5 terms in this sequence. Now we could do that for pretty much any number they ask for. In this part of the question, it's asking for the 30th number in this sequence, or the 30th term in this sequence. So all I'm going to do is find the 30th number in the 5 times table. Well, 30 times by 5 is 150. So all I'm going to do is add 2 to it. So 152. The 30th number in this sequence would have been 152. Next question. Okay, so this is the 3 times table, but moved over 4 spaces. So again, I'm going to find the first 5 numbers in this sequence. Well, the first number in the 3 times table is 3. So add 4 to it, and we get 7. The second number in the 3 times table is 6. Add 4 to it, and we get 10. The third number in the 3 times table is 9. Add 4 will get us 13. The fourth number in the 3 times table is 12. Add 4 to it, 16. And the fifth number in the 3 times table is 15. add 4 to that number, and we get 19. There is the first 5 numbers, the first 5 terms in this sequence. This time, I've been asked to find the 100th term in this sequence. Well, what's the 100th number in the 3 times table? That would be 300. So add 4 to it, and we get 304. If I continue this sequence down till the 100th number, it would be 304. What about this one then? So it's the 4 times table, but been moved backwards 1 space. So what's the first number in the 4 times table? 4. Move it backwards 1 space, and you actually get the number 3. The second number in the 4 times table is 8. Take away 1 is 7. The third number in the 4 times table is 12. Take away 1 is 11. The fourth number is 16. Take away 1 is 15. And the fifth number in the 4 times table is 20. Take away 1 is 19. There are the first 5 terms in that sequence. This time we're going to find the 50th term. So what's the 50th number in the 4 times table? Well, 4 times by 50 would be 200. So take away 1 or move it backwards 1 space would give us 199. The 50th number in this sequence would be 199. Right, the 2 times table. Hopefully we can do this a little bit quicker this time. So the 2 times table is 2, take away 3 is minus 1. 4, take away 3 is 1. 6, take away 3 is 3. 8, take away 3 is 5. And 10, take away 3 is 7. All I did was find the first 5 terms in the 2 times table and take 3 off each value. Well, what's the 35th term in this sequence? What would be the 35th term in the 2 times table? Well, to find that, I would just do 2 times by 35. That's 70. And then move it backwards 3 spaces. So 70 take away 3 is 67. The 35th number in this sequence would have been 67. Right, have a go at these questions. The first 3 corners or first 3 quadrants are just finding the first 5 terms. If you get down to these ones over here, I want to know the 8th, the 15th and the 40th term in these sequences. Pause the video here and I'm going to put the answers on there in a second. Good luck. Okay, here come the answers. There we go. So you got the first 5 terms, the first 5 terms, the first 5 terms, and then you got the 8th, the 15th, and the 40th for all of these sequences here. Hopefully you got them right. Give them a tick, give them a cross. Here we go. Right, to try and make this a little bit trickier, they often hide sequences in patterns, and it does catch quite a few people out. All I'm going to say is if you see a pattern like this one here, all I want you to do is change it into numbers. It makes it a lot more easier. For example, these are matchsticks. So I've got 1, 2, 3, 4 matchsticks in pattern number 1. I've got 1, 2, 3, 4, 5, 6, 7 in pattern number 2. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 matchsticks in pattern number 3. Now I only really need 3 numbers in a sequence, and I'll write an nth term. For example, this is going up in 3s. So like the start of the video, any sequence that goes up in 3s, I'm going to call the 3 times table. Now the 3 times table should start at 3, but instead of starting at 3, it's decided to start at 4 instead. So it's moved positive 1 space. So I'm going to say this is the 3 times table moved positive 1 space, and that's the nth term for that sequence. Pretty simple. Let's try another one. Okay, very similar, but again it's patterns. I'm not really very good at patterns, so let's change them into numbers. So in pattern number 1, we've got 1, 2, 3, 4, 5, 6 matchsticks this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 matchsticks in pattern number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 matchsticks in pattern number 3. Now, just by looking at that sequence, I can tell that it's going up in 5s. Any sequence that goes up in 5s should be classified as the 5 times table. The 5 times table should start at 5, but it's moved to the number 6 to start instead. So again, it's moved in the positive direction 1 space. So we're going to say it is the 5 times table, but moved positive 1 space. And there is our nth term for this sequence. Now, to be honest, there's quite a lot of things I could be asked to do now. It could say, like, how many matchsticks would I need for pattern number 20? And all I'm going to do is use my nth term and find the 20th number in the 5 times table. Well, the 20th number in the 5 times table is 100. So add 1 to it will get me 101. So the 20th pattern should give me 101 matchsticks. And that's how you use an nth term. It just asks you to find a specific value in a sequence. Right, what about this one then? This is a bit more confusing. You've got circles and you've got matchsticks now. Here is a sequence in the form of a pattern. How many matchsticks would you need for pattern number 20? Well, to be honest, it doesn't ask me about the circles, so I'm going to ignore the circles for the time being. I'm going to look at the matchsticks only. So 1, 2, 3, 4, 5, 6, 7. Matchsticks for pattern number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Matchsticks for pattern number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 matchsticks for pattern number 3. Obviously, I'm going to try and write an nth term for this, because if I have an nth term, I can find the 20th number, I can find the 30th number, I can find the 100th number, whichever one it asks for. So that's going to be going up in 3s, yep, going up in 3s. So I'm going to call it the 3 times table. And the 3 times table should start at 3, but it's decided to start at 7. So I think every number has moved 4 spaces to the right. So it's 3n plus 4. Now, using that, I'm going to find the 20th number. So what's the 20th number in the 3 times table? That would be 20 times by 3, which is 60, and then add 4 to it. So we would have 64 matchsticks in pattern number 20. Part B then. This time it says how many circles would you need for pattern number 18. So I'm not really looking at the matchsticks anymore, just the circles on their own. So we've got 1, 2, 3, 4, 5, 6 circles for pattern number 1. 1, 2, 3, 4, 5, 6, 7, 8 for number 2. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for pattern number 3. This pattern is going up in 2s. So I'm going to say it's the 2 times table. Again, I'm going to write an nth term because then I can find the 18th number very, very quickly. So the 2 times table should start at 2. This one's decided to start at 6 instead. So I think every number has moved 4 spaces to the right. So it's the 2 times table and an extra 4 every time. There's the nth term. So all I need to do now is figure out what the 18th number in the 2 times table would be. Well, that's 2 times 18, which is 36. So 36 moved over 4 spaces should be 40. I would need 40 circles for pattern number 18. Right, that's pretty much everything you need to know about sequences and nth terms. Hopefully you've learned something. Thanks for watching.